Hello and welcome to the 8th episode in the series where we create a 3D rendering engine. In this episode we will be going over how to create a model in Blender and then export that model and bring it into our own program. We will triangulate the model and we will also go over how to bake textures, as well as adding our own camera control, so a small game control script that lets us move around the objects to view them from all angles to make sure that it's properly been imported. Our end goal is to make something that looks like this. So we can move around and look at our object from different angles, and it will take in an object file and a texture file and render all of this. So last episode we added CPU multi-core support to our program. In this episode we will be learning how to export from Blender, and we'll also be adding our own basic movement controls. So we're going to start by going over here under Form 1 and then Form 1 Designer. We're going to expand this, and then over here we're going to write mouse move plus equals Form 1 underscore mouse move. And then over here we're going to write key down plus equals Form 1 underscore key down. And so what these are just adding events like our paint. So we're saying when the mouse is moved and when a key is pushed, we're going to run these two bits of code, which we haven't created yet, which is why it's underlined. So we can save this and go back to our main script, and then we can put at the top here our movement and rotation code. Here we can write private void form 1 underscore key down object sender key event args, and then we're going to write private void form 1 underscore mouse move object sender mouse event args. And so we'll be using these two scripts for moving the camera and then rotating the camera. So we'll start with moving, and so we're going to write vector 3 camera forward equals new vector 3, and then in here we're going to write negative float math dot sign brackets camera rotation dot y multiplied with brackets float math dot cosine camera rotation dot x, and then negative float math dot sine camera rotation dot x, and then negative float math dot cosine camera rotation dot y multiplied with float math.cosine camera rotation.x. And what we're basically doing is the direction that the camera is facing, we want to get a vector 3 of that angle, the angle that the camera is facing. But this is basically going to be, so we want to move forwards, but we're looking at an angle. We don't want to move forwards along the X or the Y or Z direction. We want to move forwards in the way we're looking. So we're taking our camera angle, and we're getting how far along the X, Y, and Z axes we should move to make the appearance of that we're moving in the direction that we're facing. So that's what this is doing. And then here, we're going to be doing it for left and right. And so we can write vector to camera right equals new vector 2. And then in here we can write float math.cosine camera rotation.y 0, and then negative float math.sine camera rotation y. That should be a 3. And that should be a 3 as well, sorry. Vector 3, not 2. Now what this is going to do is this is going to get the right vector for our camera, so that we can also move left and right. And how we move left is we simply subtract the right vector, so that we go left. This should actually also be backwards, because when we move forward we'll be subtracting this. And also this negative shouldn't actually be there, sorry. It should be like that. And then down here we can write switch e.key code, and then in here we can write case keys.w break, and then we can do S and then we can do A and D. And so basically when you push a key on your keyboard, it's going to run the script, and then it's going to check which key you pushed, if it's any one of these, and it's going to run the code in here. We're going to write camera dot camera dot camera location minus equals camera backwards. So this is going to move the camera forwards. And then we'll do camera location plus camera backwards, so it's going to move it back. And then we will do right. So moving it left would take away right, and then to go right we will add right. And so this is how we, this is the simple movement code. We're calculating the backwards and the right vector, and we're using that to move the camera. And then over here we can write this dot invalidate, and this just forces the program to redraw the screen, so that when we move it will correctly redraw the screen, so that we can actually see what's happened. And then later on you can attach this to a timer or whatever that goes at 24 times a second, so that you have a nice smooth frame rate. But if we give this a try, you'll see that we can push S to go back, A to move left, D to move right, and W to move forwards. So we can move around like this. And if we make the camera look slightly downwards, you can see that it's correctly moving at the angle that the camera is facing, which is good. Now there's one thing I need to fix from last episode, I think it was. This value here, x2, should actually be x1 in apply transformations, and same thing in apply camera transformations. This should be x1, otherwise we get a weird glitch. That should be it though. And so now we can do mouse movement and rotating the camera with the mouse. So we're going to create two new variables. We're going to write private point last mouse location and private float mouse sensitivity. And this is going to be equal to, for now, 0.005, but we can change that later. And then down here, we're going to write int delta x equals e.x minus last mouse location.x, and then we're going to do int delta y equals e.y minus last mouse location.y. And what we're basically doing is we are getting the mouse's last location and then its new current one, and we're finding the difference between these two values so that we can find the distance that the mouse has traveled, and then the direction as well, which will allow us to move the camera accordingly. And then we can write last mouse location equals e.location. So we're just updating the last location to the new one, the current one. And then here we can write camera rotation dot x plus equals delta y times by camera mouse sensitivity. And then we'll do camera rotation dot y plus equals delta x times mouse sensitivity. And what this is doing is this is getting the difference in the mouse location, and then it's updating the last mouse location for the next time we do this, and then it's actually moving and changing the camera rotation according to where the mouse has moved. And then finally we're going to write camera rotation dot x equals math dot clamp camera rotation dot x, and then brackets float negative math dot pi divided by 2 plus 0.01 f comma float math dot pi divided by 2 minus 0.01 f. And what this is basically going to do is this is going to make sure that if the mouse moves too high, the camera is not going to flip over and go upside down. We're going to limit it to looking upwards or completely downwards, and it won't invert. Now what we're going to do is we're going to create a timer that will constantly redraw the screen to a target frame rate, so that way when we move the camera we can see it. So we're going to go up here, we're going to open this, and we're going to write here components equals new system.componentModel.container. Then down here we're going to write private system.windows.forms.timer and then frame rate. Frame rate. And up here we can write frame rate equals new system.windows.forms.timer components, and then in here we can write frame rate dot enabled equals true, frame rate dot interval equals 40, and frame rate dot tick equals frame rate tick. And then we can go back into our code, and we can write here, this should be a plus. Then we can go back into our code, and we can write private void frame rate tick object sender event args-e, and then in here we can copy this and delete it, and then put it in here and save this. Now up here we're going to create a new variable called target FPS. We can make this 25, and then down here we're going to write frame rate dot tick equals 1000 divided by target FPS, and this is because interval, frame rates dot interval, and this is because this runs in milliseconds, and 1000 milliseconds is a second, so we're dividing it by our target frame rate per second, which will give it its new interval. And yeah, we can go and we can give this a test now. So if we hit the run button, there's the car. Now you will see that it's quite flickery, and this is because we need to enable something called double buffering, which means that the screen will just hold the frame until the next one has been completely drawn. So we're going to close this, and we're going to go back to our designer, and down here we're going to write double buffered equals true. And then if we go and give this a run, it is no longer flickering, and there you are. We can actually move the mouse around. It's going to move, change the camera rotation, and we can use our keyboard to move around in the direction that we are looking at. So now it is time to get go to Blender, and we'll see how we can import objects from Blender and their materials into our program. So here I have Blender open, and I have a very basic scene with a monkey on a cylinder with a texture on it. And this is just to show that any material will work for this, and import it into our program. So what we're going to do is we're going to go back to our layout, and we are going to first apply all of our modifiers. So you can either do it manually, or if you have a lot of objects, you select all of the objects and you hit Object, Convert, Mesh, and this will apply all of the modifiers. And the second thing we're going to do is we're going to join our objects together. So we're going to hit Shift, Select, Control, J. Now, in our 3D program, if you want two objects to move independently, so separate from each other, such as a race course and a car, you're not going to want to join these objects. You're going to want to keep them separate, and you're going to do this whole process for each object one at a time. So in the end, you should have if we're doing it for two objects that we want to keep separate, we should have two object files and two texture files for each object. But other than that, you join everything together. And then the next thing we're going to do is we're going to apply a modifier called triangulate. Apply. And this just makes everything into triangles, which is what our program needs. It can't have any squares or anything, it needs triangles. And now we can go on to baking. But before we do that, actually we need to do UV editing. So we're going to go to our UV, we're going to have our object, and under our object data, we're going to open up UV map, and we're going to hit the plus button to create one. And we're going to call this bake. So this will be our baking UV map. We're going to select this, and we're going to select all of this, and we're going to Smart UV project, and make the island margin 0.01 and hit unwrap. And what this is going to do is this is going to unwrap the object onto our what's going to be our texture in a moment. And that island margin is to keep a gap in between these objects so that we have room for error, because our texture is limited to its resolution. And so this is our original UV map, and this is our bake UV map, which is what we're going to use. So have that selected, we're going to go to shading, and then we're going to go, and for each of these textures and materials, we're going to go Shift A, type up image, texture, and for the first one on the list, we're just going to hit new. And we're going to call this bake. And this is where you enter the size of your texture. So the bigger it is, the more detail it will have. But that comes at a cost of performance. And also it uses quite a lot of memory. So keeping this small as possible, is the best option. And then you can just hit new image. And if we go along here, we'll find that it's just a blank image. And we can copy this, and we can paste this image texture into each material, making sure that it's selected. So nothing else is selected. This is selected in each one of these. And then we can go on to baking. So we're going to hit render, and we're going to make sure that we are on cycles, and preferably GPU. We're going to go under baking, and then this is where we can select what we want to bake. So we want to do diffuse. And then here, we want to do indirect or direct, is basically lighting. And then we want color to be selected as well. So I want to keep lighting on, but you can turn that off as well. And then you can go ahead and bake. And we can also, under render, quickly, disable noise and reduce this to about maybe 24 samples, just to speed it up, because 4096 is a bit excessive. And so you can leave it this, and then hit bake, and there it has baked our monkey and our cylinder as well. And so to test this now, we can go back to our object, and we can go to our materials, and we can remove all of the materials, and then we can plug it in our bake into our base color. And this won't immediately work, because we now need to go to our data, UV maps, and make our bake, the UV map that's selected. And there it is. It has, we can even turn off the lighting, and it has baked our light and our textures and our materials into our image. And you can see that the resolution isn't very high, so we see the pixels, but we can you can increase it when you do yours. This is just an example. And then to export this, we can go click on these three little lines, go to image, and then click on save as, and you can save it externally in your project folder as your texture. And then for our object, we need to go to object, file, export, OBJ, selection only, so that we're only selecting the object that we have selected. Uncheck normals, and we've already applied our modifiers. Keep UV coordinates on. Uncheck materials. Give it your name, and then you can save it in your project folder. So that now that we have those two files, the texture and the object file, into your project file, we can then click on the object file, change its build action to content, and its copy to output directory to copy if newer. And we're going to do the same for the texture. Now it doesn't matter if they're the same name or not. And then down here, we're going to import it, just like we did with the car. So we're going to copy this, and paste it, duplicate it, and then we can change this to demo, or whatever you named it, and then demo bake, what your texture name is, and then this should import it. And so if we give this a run, there it is. Now, another thing is, say we want to move one of these objects or rotate it. What we can do is we can write scene meshes, square brackets, and then depending on which order you put these in, so the car was imported first and then the demo object, this will determine what object we want to move. So the first object, so the car, we will put 0, and then we'll write dot either location or rotation. I'll use location as an example, equals new vector 3, and I can make this 3, 2, 0, or maybe 1. And this will rotate the car, so we can actually just copy this and paste it, and we can do the same for the demo object, but say we want to rotate it instead. So this will move the car, and if we want to rotate any objects, we're going to rotate the demo object, because this is object 0 and this is object 1. Then we can do rotation, and we can do another set of numbers like 5, 2, and 3. And then when we give this a run, you'll see that the monkey has been rotated, and the car has also been moved as well. So that's how you rotate and move objects with our program. So there's one last thing that we can change, and that is you might have found that resizing the window causes some glitches at project points. We're using the screen size, but what we can do is we can override it. So if we just delete this dot width and this dot height, delete that. So just this part, keep the width, because we actually defined that up here. So screen width and screen height. And then what we can do is we can delete this part where we set it to the size of the window, and instead manually set the size. So up here we can make it equal 480 and 320. This is setting the resolution that we're going to render at, and then from earlier on we upscale. So currently nearest neighbor is on. So if we give this a run, you'll see that it's a bit more pixelated, the rendering look. And if I full screen this, so now it's full screen for me, I can actually see that there's a lot more pixels. And it's rendering at a lower resolution, which means it will render a lot faster. And this allows us to resize the window. Increasing it will make it look sharper, but will reduce the performance. It's going to take longer to render each frame and go slower. And reducing it will make it render faster, but there will be a lot more pixels. So this will be very pixelated, as you can see. And if we turn off nearest neighbor, it's going to give more of a blurred look. So it's not quite as sharp, but maybe this is the look that you're looking for. Yeah, I would recommend anything between 720 and 480. I've found that on my computer this runs the fastest, and the resolution doesn't look too bad for a game like this. But it's up to you and how fast your computer is. That's it for this episode. The next episode will probably be the final episode, where we tidy up the program and separate all of these variables and camera controller controlling code from the actual rendering engine. Have them two separate files to make the program more organized. And then that's it. It will be up to you to create the rest of the code and make a game from it. Thank you for watching.